First off, it's great.
Have you guys seen those memes?
Yeah.
Some dude on the canoe.
Said he was going to get hard.
I ordered like this dinner.
I'm fucked down by the LSB.
Oh really? You are
Shooting if my work
This is double
practicing or
counting
prison.
No, like,
Just like that.
Yes, yes. Actually, no, he wouldn't.
He probably will. Kevin, have a seat.
Good. You?
You remember I should part?
You know what's for dinner?
Can I have some?
Yeah.
I remembered Landon when I'm balling.
Oh, that's it.
That's a really
I first had
Good, Julia. So,
once this meeting, I'm going to do everything out of my way.
Wait, I lost this job.
Soil is above.
Baby project.
hey yo. Look at this.
I know we're trying to
Alright, have you ever worked there? Because we're going to order a team. I'm sure. Oh my god. What would be bad if he's like oh yeah, I see.
I don't even know if it's 7 or 10 there. It's you do need it. Dude, I might just leave.
I'm not even in this class.
We're practicing.
I don't think so. Oh yeah. Pass through some generation. Jarvis Park in troubleshooting. Yeah, Adidas. It's all playing off each other. Now I have the other two classes like have everything over it. It's just sorting.
She's gotta have a trap. They also gave
So I have that one.
I'll worry about it.
Like was.
You guys are both my science. Yeah. But the very first time he was fighting him in the street over their lords and chiefs.
Normal every week announcement. Scooch. That will help.
the more I get it, like, we don't even get it.
Realize I've had radio since Cheers.
Your name? Oh.
Sorry. He hates us. Believe it.
I don't hate you guys anymore. What's
Man.
your name?
Colin.
Brian? What's your name?
Bennett.
Nice. Cade. Awesome.
What's your name?
I'm Rhett. Right. Got it.
Because they're like, oh, well, we know you're like.
I might think getting you could be a nightmare.
All right, everybody. Welcome to seminar. We're having an opening prayer by Zach. So quiet down.
Our dearly Father, we're so grateful to be here today. Grateful for the safety we traveled to be here and the semester that we've been able to be here for. And Father, we ask Thee that during this time that we'll be able to study and prepare for these finals and finish off this semester strong. Grateful for the opportunity to be a student here at BYU, and we say these things in the name of Jesus Christ. Amen.
Amen.
Awesome. Last seminar of the semester. Woo! Get hyped. Okay, we have some announcements.
All right, guys, if you are a woman in civil engineering and you are interested in being involved in some leadership positions, we have a few openings for next year for officers. Our elections do close, I think the 13th is Monday. I think it's on Monday is when the when our spreadsheet's going to close. So if you're interested in applying, then please fill out the form and we'll review them and get back to you like end of next week. So yeah, thanks you guys. Oh, yeah? It says expired. Well, okay, I'll fix that. And I'll send it into the teams then. I'll fix it and send it into the teams chat. So if you're interested, keep an eye out on the teams. Thank you. Okay. And Dr. Farnsworth can also email it. So.
Perfect. We have a closing social for SEAU, which is for structural engineers. So if you want to be a structural engineer and want to learn more about SEAU, we'd love to have you. There'll also be some networking opportunity and some ice cream. So we'd love to see you there.
And on the subject of closing socials, our BYU ASCE closing social is next Tuesday, 4:30 to 6:30, the field behind the EB. And there's a QR code to RSVP if that QR code is too small. That one's bigger. It's the link tree. It also has the QR code to swag and slides and all that good stuff. Please come. It'll be fun.
So today we're doing capstone presentations. This has been a tradition for quite a while. Thank you to all the familiar faces who are unfamiliar because I haven't seen you in seminar for a year. Welcome back to seminar. I'm assuming like this whole row is capstone teams because you guys are hogging the edge and won't scooch in. So I realize that's probably what's happening there. Dr. Jug's plugging in right now. I believe there's an order for you guys. And you know the drill. You got to be done by 10 too because people are just going to leave by then. So, right? All right. Give us just another minute or two. Who's team number one? What may work? Well, you have some advice.
We're going to do team 14, then we'll go in order.
Team 14, and then we'll go team 1. I don't know why. And probably the best thing to do so we keep this thing speedy along is have the next team also sort of on board, on deck. What's the baseball term?
On deck.
On deck. Thank you. So 14 and team number 1 on deck. Number 1 or number 2, you can stay in the hole wherever you're at. Are you guys presenting from right there? Come up. Oh, gotcha. I don't need you guys on there. Oh, you're in seminar.
Is it just the net ID is like?
Yeah, just
Thanks.
I'm like sick. Thank you to our seniors for being here. This is awesome. We do some pretty cool projects. I'm excited to see what they are. So for the rest of us, give them respect. Glad they're here.
Alrighty, so our Capstone team created a culinary water master plan for the town of Walsburg. Walsburg is a town of about 300 people up near Deer Creek Reservoir. The purpose of this master plan is to do a few different things for the community. First, we want to describe what the water system's like right now, what it's doing well, what it's not doing well. We want to plan for future growth about 20 years out, and we want to propose some infrastructure upgrades that the city should focus on over those next 20 years. The first few steps we took in order to do that were to look at some meter data to see how much water they're using right now. We projected the population growth over that time frame, and we predicted where they're likely to have new connections be added to the system as well.
Yeah, so in order to see what was wrong with the system, we made a model using EPANet, which was great because it was free, but it allowed us to put in all the pipe runs, the node elevations, and the storage locations. After that, we calculated the peak day demand and the average daily demand. We were able to put those in. One of the problems was their fire hydrants are having issues, not receiving enough flow. The state of Utah requires 1,500 gallons per minute. And so we put those in individually, and we were able to identify several fire hydrants that were not functioning because they just physically couldn't. And then we also found that the entire northwest area of town was low in pressure.
Switch my slide. To address the needs presented by the Walsburg system, we proposed a 4-phase capital improvement plan. Phase 1 addresses the immediate safety needs of fire flow. By increasing the size of pipe the fire hydrants are connected to, this immediately brought the fire hydrants back to code compliance. Phases 2, 3, and 4, can I see another slide? Centers on the installation and connection of a new water tank at a higher elevation for the lower pressure zone. This new water tank provides a greater amount of pressure for town, but also the installation of a feeder hose from the reservoir and also pressure reducing valves to the connection point. In this way, this setup and this system will be able to provide Walsburg with the proper pressure now and the proper pressure for years to come. Thank you.
Hello, we're Nora, Sam, Tyler, and Quentin, and we are the geotech team. Our project is the geotechnical evaluation for the US Highway 89 bridge. No, that's not the bridge. The highway bridge hasn't been built yet. Our job is to let our clients know if, if it's safe to build where they want to build.
So basically our job was to characterize the soil at the site to determine how suitable it was to build the bridge. And we did this by drilling an 80-foot borehole, and then we had to characterize the seismic and slope stability characteristics for the site, as well as provide foundation design recommendations. We did this first by doing some field work with the drilling, then taking soil samples back to the soils labs for testing, and then doing analysis with math and Excel.
To get the values that we needed, we ran a different series of geological tests. We did consolidation, collapsible soils, expandable soils. We did gradations to determine what we were actually dealing with, as well as calculating the density and moisture content of the soil in situ.
So after all the Excel and stuff like that, we basically had to come up with some recommendations using our bore log information, using our testing information. And we found that there was about 12 feet of fill on top of the native soil that was pulled up when they built the railroad. And so we recommended that we build a shallow footing for our bridge so that it could take all the bearing capacity, spread it across the width of the bridge, and we just put some nice sand or something underneath. We also found that the sand is, or the natural fill is pretty much good enough for the base of a road, and then we just put asphalt and everything on top of it. And then we just determined if we needed to, we could use some piles to replace the footing if necessary, if the contractor wants to. But that's our project. Thanks.
Okay, hello everyone. My name is Josh, and we are the Nauvoo Dugouts group. This is our dugout design, and the purpose of these is that they're supposed to mimic the types of structures that the pioneers had to build when they were traveling west. And so they built these types of structures when they were in winter quarters because they didn't have a whole lot of building materials. And so these specific ones that we're engineering are going to be built at Camp Mary B. Smith in Nauvoo, Illinois, for youth groups who are going to come during the summer. So it'll give them some bunkhouses to stay in to give them an authentic type of experience. One thing that was really fun about it is that we got to go and do a site visit. They flew out 3 of us, and we got to go and help them kind of develop the land and figure out what their plans were. And so this is the outline of our dugout, and then we got to get some soil samples as well.
So one of our design challenges for this project was building and designing a retaining wall. So the back wall is almost completely underneath the ground. And so we had a number of different design options. One was a reinforced concrete normal retaining wall. But we also had some other options like counterfort walls that would add structural integrity, but wouldn't be as efficient with the amount of concrete that we were going to use. And so through the design, we took multiple steps, starting with the normal retaining wall design, and then we analyzed the counterfort option, and we actually ended up deciding on a third option that's not even present here, where the heel of the retaining wall is actually very short, and that was to reduce the cost of excavation in construction, which is really interesting to explore.
One of our other fun design challenges was originally when the architect gave us the plans, they wanted to do a green roof. So bring the hillside just up onto the roof and create a grassy patch up there. But after going through and designing for the dead loads up there, we found that it was significantly over 100 PSF, and we would ultimately either have to use timbers, glue lams, or LVLs, or 2 2x12 sistered together, which we decided was too much in the construction and the cost. So we talked about doing a wood chip roof instead, which was the green roof was 3 times bigger than the wood chip roof. So ultimately we could bring the dead load down, allowing us to be able to have easier constructability and way less cost.
And so for our deliverables for this project, we're turning in our CAD drawings in addition to our spreadsheet with all of our calculations. Right now we're just finishing up our report and some of our details. But otherwise, this is going to be at Nauvoo here soon. So if you go there, check it out. But otherwise, that's our Capstone project.
Alrighty, so our team was tasked with designing a pavilion for Camp Nauvoo alongside our dugout friends. And it is an 18 by 36 foot structure with about 2/3 of it being an open layout for seating guests, having meals, meetings, etc. And the other third is an enclosed space consisting of a kitchen, 2 bathrooms, and an upper storage attic space. And so we were provided with drawings from the client and was expected to run structural analysis on the various components of the pavilion and then deliver back plan sheets for the roofing frame, upper floor, foundation, and then detail sheets for the contractor to be able to use.
Yeah, so as Nakia said, our main deliverable was the structural plans. And so here we have, this is our roof framing plan. And one of the main things that we first started with was we had grid lines, so it was easier to discuss when we were talking with the client. And overall just to center the plans. Then from there, we added schedules so that we can make it more legible and just call out our beams, and then the contractor can go up there to determine what beam to put in. And then from there, we called out details in order to specify how it's actually to be built, as this plan sheet just gives more of an overall view, and the details give a very specific detail on how to build it.
Yeah, so we made 18 details to help the contractor build the pavilion. Here are 2 of them. The top one, we were talking with the client, and he was worried that the dirt below the slab would get eroded from water, and so we decided to do a thickened slab edge. And so basically, at the very edge of the slab, we just dropped it down a little bit, so then the soil will be above the concrete and we won't have to worry about erosion.
Another thing that the client was worried about was maintaining an open space. So to make sure that we did that, we had our columns in the structure be cantilevered instead of using cross bracing. And if you guys remember from statics, a cantilever is difficult to design because small loads at the top can have large forces at the bottom because of moments. And so because of that, we ended up with a pretty beefy foundation plan. But overall, this was a great structures project where we could apply what we learned in mechanics of materials and statics and soil mechanics, and we're pretty happy with what we came up with. Thank you. That's it.
Eagle Mountain, Utah is one of the fastest growing cities in the state. They're anticipated to more than double their 2010 population by 2030. As a result of this insane population growth, they're seeing severe traffic congestion in and out of the state, or in and out of the city. To combat this, the city and MAG are wanting to connect Pony Express Parkway and Mountain View Corridor through expanding Mid-Valley Road over the Lake Mountains, and our project sought to find the best way to do this.
So we each designed one alternative, and we then compared these alternatives based on design criteria, such as like volume analysis, cost estimates, travel time, and as you can see, it was pretty steep. We're going pretty much straight over a mountain. So one of the biggest problems with this project was trying to keep the road shallow enough to be drivable, as well as to balance the cut and fill and make it realistic.
As you can see here in our vertical alignment, on the west side of the mountain, it goes very nicely, slopes all the way up, and then we hit the peak, and we have to cut over 100 feet of the mountain in order to make the road feasible to actually go down the mountain. And then right here, we also have to fill in tons amount of soil to keep that slope to make the road actually drivable, especially in potential snowy conditions. So in order to make this possible, this road will have to employ 2 different types of retaining walls, such as soil nail walls for when the mountain needs to be cut, and MSE walls for when it will need to be built up to meet the correct grades.
And as you can see here, this is our horizontal alignment design. In some of these locations, like Connor was saying, we need to build up the earth or cut away the earth with these retaining walls. You can see here in a location like this or like this, there's significant grading that would be required, and that will be really detrimental to the environment, to the landscape of the mountains there. So implementing these walls helps us to eliminate all of those areas. It's a little bit expensive, but in the end, it's better for the environment, and it's just better overall structurally. our recommendation to MAG was that they needed to acquire funding for this immediately if they're planning on working on this, because it's a super expensive project. Traffic is just going to keep increasing in Eagle Mountain, so if they're not going to do this alternative, they need to find something else to do in order to alleviate that traffic. So, thank you.
Testing 1, 2, 3. All right. This is the Bluffdale South Water Detention Basin. I'm Joseph West.
I'm Matt.
And that's Sam over there. All right. So our project was to design a stormwater retention basin. Basically, Bluffdale is expanding very fast. And unless they find a way to manage all this water, then it's going to start flooding. So our job was to go in and figure out where they could build water detention basins and how to better manage that stormwater.
Alrighty, so how we did that was we went into a program called Storm and Sanitary Analysis, and we put together a 1D model. Similar to one of the other groups, we put in nodes, junctions, and sub-basins, and we made it rain. We put in a 24-hour storm. Obviously, detention basins are pretty big, so we're designing for a 100-year storm. Quite a bit of water is going to be moving and being routed there. So we decided to split up into 2 basins for one of our alternatives. So one thing that made this project pretty tricky was we had 2 options for a discharge point. One was in the Jordan River, which could accept 0.2 CFS per acre, and the other was a canal, which could accept 0.02 CFS per acre, which is not a lot. The one catch, which Sam will hit later on, but we had to capture quite a bit of water, over 22 acre feet, which is quite a bit, in an area of about 82 acres.
Yeah, and so like I guess kind of like other constraint with that is the topography for our study area. It was very hilly, and you can imagine how difficult that would be for routing and our design choices and whatnot. And then kind of like what Matt said about the other constraint, the railroad. If we were to choose to discharge to the Jordan River, that would just lead to an increase in costs. And as engineers, you're always trying to do the most economical choices, right? So just that. And then over here, we actually made 3 alternatives, but we chose to opt in for our first alternative 1. This one avoided the going underneath the railroad, and so we discharged into the canal. And then as well, this would just lead to more water, which is great. And then with this alternative, we had 2 detention basins, which were a total capacity of 1,224,000 cubic feet, or about 28 acres. Thank you.
I'm gonna have to get on my knees so you can see what I'm doing. So, hi, I'm Nicholas. We are the Upper Stillwater Bridge Capstone team.
I'm also Nicholas.
I'm Max.
And I'm Thomas. We were tasked by the Central Utah Water Conservancy District to analyze the Upper Stillwater Bridge, which gives critical access to the Upper Stillwater Reservoir and Dam. Part of the reason for this analysis is they don't have great documentation over the past 40 years of the maintenance or the repairs that have been made to this bridge, and so an analysis and recommendations for repair was pertinent.
To assess the bridge, we performed a site inspection and we used 3 methods to evaluate its current state. We measured cracks using a crack card. We checked for delamination using chain dragging, and we took photos of any notable features or damages we found on the bridge.
Based on our findings, we took those findings, we looked at the photos that we had taken, and we classified the condition of the bridge. Overall, we thought it was in fair condition, and we used standards from AASHTO and the Federal Highway Administration to grade the condition of the bridge.
After this analysis, we determined that there were 3 areas of concern on the bridge that needed immediate repairs. The first was a simple fix. This was a broken edge angle, most likely broken by a snowplow, and so our recommendation was simply to grind it down to prevent further damage from snowplow or damage to the edge of the bridge.
We noticed that there was some significant deterioration at the central expansion joint that's between the 2 deck slabs. There is a seal that has completely failed, and there's debris down in that joint. So if water is leaking through, we recommend that they replace the seal and make it watertight again.
Our last concern was the north edge of the concrete pier cap and pier wall below it. For the concrete pier cap, we recommended cutting out the exposed reinforcement and filling the treated area with repair concrete. And for the pier wall, we recommended chipping off any loose or damaged concrete and applying a protective seal coat.
Beyond those individual repairs, we also made a maintenance plan for what they can do for the next few years. Each year, they should be cleaning the bridge, sweeping off any debris, and making sure that water can just get off the bridge. Beyond that, codes require that at the maximum every 6 years, another bridge inspection should be done. And yeah, that was our Capstone project.
All right. Who here likes taking showers? Raise your hand. There are not nearly enough hands up, by the way. Okay, who likes taking showers on a hot day? Raise your hand. Right? Yeah, okay, so if all of us decided to take a shower all at once, if it weren't for tanks, we would not have the pressure to be able to do that. So tanks are really important. Our Capstone project was to determine the size, elevation, and location of a new tank in a little town up north called Mountain Green. The first group covered something called a master plan. They designed one. We used a master plan for part of our project. So basically that just details every single structure that has to do with getting your water to you in a city. So we have Mountain Green's master plan right here. This is the existing system, but they're expecting almost like a 40% increase of population in the next 20 years. So it needs to get revamped a little bit. This shows where they expect the population to grow, the areas. And like other groups presented, there is a model of this drinking water system, an EPA net that we use. This is the existing model. And we needed to update that model according to the future growth and determine where we could put a new tank in to account for all that growth and all that extra water that people need. So, first, to determine the tank size, we did some pretty simple calculations. We knew how much water we needed to store, so we decided to create a circular tank with a 123-foot diameter. The elevation we determined using the water distribution system model in EPA net that we updated according to all of the new growth. We modeled those locations here. We added a couple new pipes, and we modeled a tank, figured out what elevation we would need to supply the proper amount of pressure to get everyone their water. And then finally, the location, we did some really cool analysis in ArcGIS, and we, Mountain Green's really mountainous, and we don't want to create any landslides, and we don't have any tanks falling down hills. That would be bad. So we had to set a slope that would be appropriate for a massive tank to be built on, as well as the proper elevation, and private land ownership status was important. So taking those three factors, we made a map of all the appropriate or suitable spots that we could use, and then we selected a couple of them to assess in a further analysis.
So when it comes to selecting the best tank site, sorry about that. As you can see, like we've discussed before, we put in all this new demand, the equivalent of like basically 2,000 homes using up water. And with that demand modeled, there's a few criteria you can use to select the best tank site. The biggest one is pressure, is what we were looking at. You can't have pressure too high, which is a little hard in a mountainous system. But at the same time, you also can't have it low, which is prone to happen during your peak demand periods. So your tank elevation is what determines what that pressure will be. And we needed to find elevations that would work to supply enough pressure while also still working to not, blow out people's water systems if the pressure's too high. Once we selected those tank elevations, we were able to come up with sites according to our GIS analysis of slope and also geotechnical factors. And then once we had 4 sites selected, we then made a cost analysis of each of our 4 potential sites based on how far it was to the system and how much it would cost for pipe, how much the land would cost, all of that. And with that, we came to the conclusion that this second site, which would be up in kind of the northeast corner of that system, that would be the best spot for our tank to go. So that's our final recommendation. The second site worked the best. That'll provide a good location. It's easy to get to. It's easy to hook up to the current system, and that'll be the best site for them to put a tank for their future growth. Thank you.
All right, so we're the Salem Debris Basin. I'm Dalton.
I'm Parker.
I'm Bradley.
And we were tasked with building a debris basin in Salem, Utah. In 2018, there was a series of wildfires in the Woodland Hills and Loafer Canyon area that affected the runoff in that area, leading to an increased amount of sediment and water going into the neighborhood below. So our first step was building a water model using WMS to determine how much runoff we will get in a 100-year storm.
Using that data from the runoff model in WMS, we went in Civil 3D and created some options of debris basins. On the left there is an option that just is a debris basin that's the same elevation all the way around. On the right is one that's a stepped elevation. So it's 13-foot depth on the right side and 20-foot depth on the larger parcel. We did that because if you slope the parcels in too much, you'll end up with kind of a V, a strange kind of inflection point in the smaller parcel there. And so we wanted to maximize depth. Ultimately, what we decided is that the two-step parcel, two-step debris basin is the better option because it maximizes volume.
And in order to make sure, can you actually go to the next slide? In order to make sure that we can have water flow out of the system, we needed to design this outlet structure, which is a 48-inch pipe that needs to be totally encased in concrete. So they'll set this pipe and then they'll pour concrete around it. And so we needed to size or select some steel rebar to protect that concrete against any temperature or shrinkage. That's all mandated by ACI 318. And then this is what the overall section is going to look like. We have an auxiliary spillway that you can see in the top there. That if the debris basin floods or there's a bigger storm than we anticipated, that there's space for that excess water to flow out of the basin. So that's our project. Thank you.
So this is our
All right. So the question was asked, who likes taking showers? I'm going to ask, who likes Porsches or Porsche? Yeah, I might never own one. They're really cool, though. So before this project, if you wanted to buy a Porsche, you had to drive all the way up to Salt Lake. With all the Silicon Slopes and all the success happening down here, Ken Garf said, hey, we want a Porsche dealership in Lehigh.
Like Ryan said, our purpose, our task as a Capstone team was to help with the site design for this Ken Garf site development for this Porsche dealership. We did this in conjunction with Kimley Horn. They were the real-life team on it, and they gave invaluable advice as we went around. We got to do a site visit with them. It was real cool. Ryan got to fly his drone. We got aerial image and could kind of see what was actually built and compare that to our work, which was a pleasure.
So we have 2 team members who are working today, but they recorded a little video to share with you guys.
So this is our final plan that we came up with, and on the right is the actual one that was built. There's a ton of different ways that you can lay out a site, and there's a lot of different codes that we had to follow that affected this layout. For example, we had to include a certain number of ADA stalls. We had setbacks from the property line that we couldn't build on, and we had to have certain widths for the drive aisles, parking stalls, and curbs. And all of these codes led us to this final layout.
So the plan sheet on the left not only shows our site, but it also shows our utility layout as well. On the left, you can see the blue lines that show the water connection to the building. There's 2 of them, one for the culinary or potable water, and one for the irrigation line that services our fire water system. In the green, you can see our storm drain design. We have a big storm tech in the parking lot in the bottom left, and all the lines that connect to the roof to collect all the precipitation from the site. We also have our sewer that services the building and connects to the city sewer system in the brown or dark green color there. And overall, we've been able to design all the utilities so that the building is functional, has potable water with sinks, bathrooms, and toilets, and everything else.
We're not watching that. Thanks, everyone.
How's it going, guys? My name is Joseph.
I'm Brad.
I'm Taylor. And okay, we can't quite share what the restaurant is, but we're working on a restaurant, and this is our quick serve project. Now, this is the location. It is in Orem. You've probably driven by it. There's an old restaurant that is being torn down, and there's a new restaurant that's being built. And essentially what our job was to redesign a parking lot that is efficient, safe, and up to code. Now, where my job comes into the team is I was in charge of the city code. So essentially what that looks like is I would look into the city code for Orem and make sure that our project was going to be up to standards for Orem.
And once we had researched a lot of that city code, we were able to take the architecture plan that we were provided by Kimley Horn. We also worked with Kimley Horn. But there were some kind of big design flaws, including where the drive-through entrance was, and all the line spacing and setbacks were not up to Orem City Code. So we had to eventually edit a lot of that to create an actual site plan that is functional and usable. And that is the picture that is on the far side of that image. As you can see, we moved the drive-through entrance to the further side of the property so that it made a little bit more sense to flow, especially on such busy streets.
And then that led to kind of my portion of the project. I was in charge of the utility design. So this included all of the regular utilities that come with a quick serve restaurant: gas, culinary water, sewer, storm drain, electric, communications, and identifying appropriate connection points for each of these utilities at the building site. Additionally, we had to identify a location for like a grease trap, because this specific quick serve restaurant makes a lot of greasy chicken fingers, and so we needed to find a correct location so that sewage could be disposed of properly. And then we had to do some hydrologic calculations for a storm drain system. Orem City Code required that all stormwater runoff be detained on site, and so we had to design a detention basin large enough to hold all of the runoff that would accumulate from a 100-year storm at this location for this landscape and site type. So.
Thank you.
Okay, our project was the 2700 bonus building. We were tasked with creating a residential plan for a house in Spanish Fork, Utah. So we needed to do a gravity design and a lateral design using different code books and references like the NDS and the SPIDWIS. So,
like Hallie said, really the base of our project was designing the structural framing for a home. These are the architectural plans that were given to us by LEI, our sponsor, and obviously we had to fit our design within the frame of the home so that it would blend nicely and safely so the occupants of the home could have a nice place to live.
Something that we had to learn to love is red lines, and as civil engineers you're going to love red lines in the future. Thanks to Josh, our industry mentor, he gave us some feedback on some things that we could change and look into when it comes to gravity, lateral loads, and the different beams that we could use throughout the home.
And here's our final draft. So we're only including 2 plans here, just a snippet of those 2 plans. This is the roof layout, and this is the upper floor layout. And this is just showing specifically the bonus area, because this was what was most important here. And as you can see, there are some labels here that says, okay, well, attic trusses here and there, just to indicate, for example, here there's complicated framing too. And well, we have more layouts, but we're not showing here. But this is our project. Thanks.
Who here feels like it's really easy to find housing and parking in Provo? Not very many people raise their hands on that one. Well, Utah County is supposed to, in the next 30 years, some projections say, surpass Salt Lake County in population. So there's a big need for housing. Our project, I'm Easton Clough. This is Michael Kretschmer, Bailey Dykes, and Ezra Moreno. And we were working with LEI, a company based in Spanish Fork, on a subdivision development in Mapleton, Utah, on a 10.5-acre parcel.
So this lot was designed for residential housing according to the R2 code in Mapleton. The code required that the lots be a minimum of 10,000 square feet with 80-foot frontage. To accomplish this, we went through a few different lot layout proposals, and the one we finalized is the one shown on the screen, which contains 39 lots and 3 roads. It also was designed so we had easy access to utilities that exist in the road to the west.
So next, our utility lot plans were dictated mostly by our water lines. We had to make sure that any proposed water lines we put down would connect to existing water lines. That's kind of important for our sewage, our stormwater, and our what's called storm drains. And you can kind of see those in these like blue, green, and pink lines. And like Michael said, we already had an existing road on the west side with existing utility, and so we also had one on the southern side of the parcel. But our north side did not have any existing utilities in the road that was already there. So we proposed to add utilities into that. And from there, we can ensure that all the houses that we proposed can connect to utility line that would eventually connect to our main lines of interest.
So then the final part that we had to consider was the grading onto the existing infrastructure. So the challenging part of this is that all of the roads were about the same elevation. So we had to create several high points to allow the water to flow to the existing roads. And so you can see that with the way the sewer design and our sumps are. That's our project. Thank you.
Hey everyone, we are Team 13, or as we like to call ourselves, Team Africa. Our project has to do with church buildings in the Africa Central area. In 2025, they saw huge growth in membership, especially within the Democratic Republic of the Congo. It takes about 6 to 8 months to construct a building the way they are currently constructing them. So our job was to come up with new materials that they could use that would greatly increase the constructability and greatly reduce the time required to construct each building.
Awesome. Okay, so their current materials that they're using are clay or CMU brick. The clay brick is just built in local villages, very rural, very non-uniform. The CMU brick is a good option. It's like CMU blocks here. It's just you can't get them to a lot of these rural locations in Africa. So our first solution was using interlocking soil stabilized blocks. So we came up with good procedures for testing the soil to make sure it works and make it uniform, and then a process for designing the blocks. And then we also came up with a waterproofing solution using animal fat and quicklime to create a waterproofing on the outside of the blocks, which was pretty cool.
So the area planner in the Africa Central area wanted an on-site construction technique as well as a prefabricated technique. So we also recommended using sandwich wall panels and lightweight concrete panels. The sandwich panels are a super lightweight concrete coated panel system that can be installed by just a couple laborers, and it greatly reduces the construction time. And then the lightweight concrete panels we recommended are just your typical prefabricated concrete, hopefully using lightweight concrete so it's easier to install in rural areas.
Our final aspect of this project was creating a decision analysis tool that takes all of the options and ranks them based on availability, speed of construction, and cost. So this is an example of one location where the interlocking soil stabilized block is the best option. That's it.
All right, give me 60 seconds and I'll get you out of here. Thank you to our seniors. How many of you are graduating? Mostly those who just presented. Awesome. We'll see you in graduation in 2 weeks. How many in seminar are not graduating but done with seminar? Congratulations on that too. It just means you're a 5th or 6th year senior. All right. The rest of you, I assume I will see you next year in seminar. Thank you for a good semester. Make sure that you complete all the attendance requirements, anything. If you got makeup, make sure they're all in there. Check off your activities and all that. And otherwise, you'll get an email from me. Okay. If you missed the roll,